Okay, one thing I noticed in looking at lesson 6, homework 6, is that there was an error on the assignment that I did. I wrote down that the square root of 18 was equal to 3 square root of 3. That is not correct. It is 3 square root of 2. And the reason why is the square root of 18 is 9 times 2, which gives you the square root of 9 times the square root of 2. The square root of 9 is equal to 3, thus it is 3 square root of 2. And that is the exact value of the square root of 18. Now I noticed that on the answer I had it correct, and the reason why was because in my calculator I just typed in square root of 18 rather than the 3 square root of 3 that I had put down. So that's something that I wanted to correct for you guys so that you would realize that sometimes there's errors, and that's okay, but I want you to understand it. The other thing I wanted to look at again is the equilateral triangle. Remember, in an equilateral triangle, you have 3 sides, and all 3 sides have the same length. And I'm not real good at drawing them, but all 3 have exactly the same length. All the angles are the same, and they all measure 60 degrees. But none of our angles are a right angle. So when we go to calculate the area of an equilateral triangle, the first thing we need to know is what is the height of this equilateral triangle. And the height splits the base in 2 pieces the same size. So if this measurement is S, the measurement of 1/2 of the side is what this piece would be. So this would be 1/2 S, and this is a right triangle now on either side here. And so my H, which is what I need to do my area of a triangle, which is 1/2 times base times height, my base I know, it is S. My height I do not know. And so we have to calculate that one. So we're going to look at it in general so you will know what it is no matter what the side is. So we're going to use S for the side. So this side is 1/2 S. This one is S, and the H is what we don't know. We're going to use the Pythagorean theorem, remember? A squared plus B squared equals C squared. Only in this case, our A squared is 1/2 S, and that whole thing has to be squared, plus my H squared, which I don't know, and that's equal to my hypotenuse squared, which is S squared. So when I square this, 1/2 times 1/2 is 1/4 S squared, plus H squared is equal to S squared. Well, over here I've got a 1/4 S squared that I'm going to subtract from that. So I'm going to rewrite that as 4/4 S squared. And I'm going to have H squared is equal to 4/4 S squared minus 1/4 S squared. And that is equal to my H squared. When I subtract 4/4 minus 1/4, I have H squared is equal to 3/4 S squared. Now, have to undo my square by doing a square root. So square root this and square root this. So my H is equal to square root of 3 can't be simplified, so that's square root of 3 over the square root of 4, which is 2, and the square root of S squared is S. Okay? So my height is equal to, I like to write it as S square root of 3 over 2. Okay? So that is what my height of my triangle is. So remember, the reason we're doing this is so we can find the area of the triangle, which is 1/2 the base times the height. So this is my height. My base is S. So my area of my triangle is equal to 1/2 times my base, which is S, times my height, which is S square root of 3 over 2. And we can write this S as S over 1 so that they're all at the same level. And I end up with s times s is equal to s squared, square root of 3, over 2 times 2, which is 4. And that gives me the area of an equilateral triangle. And whatever the side is what my s is going to be. So, if I said my side was 10 inches, okay, let s equal 10 inches. All I have to do is plug it in here. The area of my equilateral triangle is equal to 10 squared times the square root of 3 over 4. Well, 10 squared is 100 square root of 3 over 4. 100 divided by 4 gives me 25 square root of 3, which is approximately equal to, let's see what it is, 25 times 3 square root equals 43.3. And that was square inches. Okay? So there you are. You can see how you can use it to figure your area of an equilateral triangle fairly quickly and easily through this. So now say you had a hexagon. A hexagon has 6 equilateral triangles. And so if you know the side of your hexagon, and I'm not very good at drawing these evenly, if you know the side of one of these, then it's going to be whatever that side is plugged into our equation here, and then multiply it by 6. So say our side was equal to 10 inches, what we just figured out. Since this is going to make 6 equilateral triangles that are all the same, even though they don't look it in my picture. Okay? So 6 equilateral triangles that are all the same. So 6 times what I have here would be 150 square root of 3, which is equal to, let's see what it is, 259.81 square inches. Okay? So as you can see, this gives me now the area of a hexagon that has a side measurement of 10. It started first by figuring the area of one triangle in that, multiply it by the 6 triangles that make up that hexagon. So you can see you can start from a base and go from there to the next step to the next step, and it just gets bigger and farther along as you go along. So that gives you your area of that hexagon. And any of your regular polygons with sides more than 4, you will use this exact same idea. You're going to look at the area of one triangle and multiply it by the number of triangles there are. And the number of triangles will be determined by the number of sides that there are, because every side of a regular polygon forms one of those triangles going into the middle. So it's really important that you understand that. All right? Any questions on that? Now we're going to look at an irregular polygon. And this one we're going to put a few little parameters on it to make it so it's easier for you to do it with your knowledge at this point. Okay? Okay. this one, what we have, if we want to know the area of this thing, the first thing we need to know, oh, this one I didn't put on. Let's go 6 feet and 6 feet. And this is the same, okay? So what do we have here? Well, we have actually a 6-sided polygon, but it is not a regular polygon because the sides are not all the same length. We have these the same with these the same as that, and this are different. So therefore, it's more of a stretched out kind of a polygon. So we're not going to work from triangles on this one. What we're going to do is for the area of this and this, if I put them together without the middle part, I would actually have a square. And the area of the square is 6 times 6. In other words, side to side is 36. And that would be square feet. Okay, square feet. So we know what the area of these two are, but we need to know the area of this one. And the only way to figure the area of that one is we're going to have to figure out what the length here from the top to the bottom of this particular hexagon is, okay? So how are we going to do that? Well, first of all, notice that this is an isosceles triangle. Therefore, this angle is 45 degrees, and this angle is 45 degrees. This one's the same. So we can work with one end only. And therefore, if this is 45 degrees, and I drop the diagonal here, this is a 90-degree angle. So therefore, this one is 45 degrees, and so is this one. So what we're dealing with is isosceles triangles on top of isosceles triangles. And if this is true, that they're isosceles triangles, this side has to equal this side. So I'm going to label these x. So x squared plus x squared has to equal 6 squared. Do you see that? This is the hypotenuse of this right triangle. And this right triangle has the legs are 8x, because we don't know what they are yet. So now we've got our Pythagorean theorem. So 2x squared is equal to 6 squared. 6 squared is 36, so let's go ahead and write that down. And divide by 2 on both sides. So I have x squared is equal to 18. So my x is equal to the square root of 18, which is equal to 3 times the square root of 2, which we worked out at the beginning of this video. So you see, we're right back to that particular figure. So therefore, this x is 3 square root of 2. This one up here is 3 square root of 2, which makes the length of this piece of this particular shape 6 square root of 2, because we combine like terms. So now I have the area of this center piece, this rectangle, is 10 times 6 square root of 2, which is equal to 60 square root of 2, which is approximately equal to, let's see what that's approximately equal to. 60 times the square root of 2, well, let's turn it back on again, is 84.85. And we're going to add to it the 36 from the square, and we end up with 10, 12, 120.85 square feet. So as you can see, that irregular shape, you can also figure it out, but I needed to put a few more parameters on that would give you the ability to actually do it, because as long as you've got right triangles, you can do a lot of things. So that helps a lot by putting that parameter on. Okay, that takes care of that video.